let's consider adding two vectors by their components. So first, let's go ahead and draw a coordinate system. I'm going to be specific with some values here. Okay, so those are some tick marks. Let's suppose our first vector looks like that, and our second vector looks like that. So we'll call this A and B. Okay. This could be an initial position vector, and this could be the displacement vector from that position. I want to add them together to get the final position. Okay, but we'll just keep it generic to focus on the mathematics of adding these. Okay, first, I can notice that A has a component in the x direction that much, okay, and a component in the y direction that much. So here's A, y, here's A, x. Now B has a smaller x component, that's bx, and a smaller y component, but it's also negative, that's by. Okay. And looking at the units, I see AY is 3 units up and BY is 2 units down. So if I add those together, I get a total of 1 unit up. So I'm going to be 1 unit up on my new vector. And AX is 2 units to the right, and BX is 1 unit to the right, so there's a total of 3 units to the right. So my net result then is going to be this vector. Okay, it's 3 units to the right and 1 unit up. Now if I were to draw it from this, if I were to carefully get these two vectors in, I'd start with one that goes over 2 and up 3, and the one that goes down 2 and over 1 gets me right there. And so it does do the same as we saw graphically earlier, but what's more important here is this helps us to find the values of the components of the resultant vector. Okay, so here I could report then C is equal to 3x hat plus 1 y hat. Okay, now mathematically that should work out too, because A was 2x hat plus 3 y hat, and B was equal to 1 x hat minus 2 y hat. And Cx is equal to Ax plus Bx, which is equal to 2 plus 1 x hat, and Cy is equal to Ay plus By, okay, and that's going to be equal to 3 minus 2 y hat, giving us 3x hat and 1 y hat.